Everyone, welcome back to the workshop. And I've done a number of laser reviews on this channel. And if you've watched some of them in the past, you will see some common threads of things I tend to pick out as areas of improvement I'd like to see on lasers. Well, we've got a new laser in the shop today. And interestingly enough, this one has addressed a number of my concerns from the past. And so I'm excited to share this with you. And we're going to take a look at it. This is the newest one from Sculpfun, and they have changed a lot. This is the SF-A9. This is a 40/20 watt blue diode laser. It's got a lot of cool features, and they've listened to mine and probably other reviewers' comments on things to improve. So let's jump into it, and I'll show you what those are. All right, so here we are with the Sculpfun SF-A9. You will notice right off the bat, there's a number of changes from their older machines. And we are not really going to go in depth on the build because it is very simple. It comes mostly assembled. They do have a really good manual in a number of languages, and this has some pretty good diagrams in it to walk you through that. The primary steps are to install the gantry rail onto the main frame. From there, we also need to add the feet, put in the antenna, and then we slide on the module, attach cables, air hose and such, and then connect up your power USB, and it's good to go. It really doesn't take too long. The manual walks you through it, so it's a very simple process. What you'll also notice is this is not your typical Sculpfun frame. Typically in the past, they've been built out of the 20x20 extrusion, maybe in some cases a 20x40 on some of the larger modules, but they've gone to a custom all-metal frame here, and this is very stout, very sturdy, and what's one of the nice features over that screwed together extrusion, while that is a great material to work with, allows for customization, expandability. This is going to be far more sturdy. It's going to allow for faster speed to be able to sling around a heavier module. So visually, it does not look like your typical Sculpfun laser. This is kind of a major redesign for them, and it's really cool to see. Some of the basic specs on this one, as we mentioned earlier, this is a 40 watt laser, but it can switch down to 20 watt. That turns off half the diodes in there, which in theory should cut down the size of the beam, allow you to have higher quality engravings at the lower power, but then also bump it up to the 40 watt if you want that extra cutting power. As far as working area, it does have that typical 400 by 400 millimeter or 15 3/4 inches square working space. And so it's going to be right in there with a lot of your typical open frame diodes, which also means that it is going to fit into most enclosures. As far as engraving speeds, this can operate up to 36,000 millimeters a minute, which is also 600 millimeters a second. So some very high speeds there. And of course, most of that's going to be more on your engraving area. And depending on your material, you may or may not be able to run it that high, but the machine is capable of it. So depending on your material, you'll be able to run those a little bit faster. Let's jump back into some of the features on this. We've talked a little bit about the frame, but let's go more into some of the details they have on there. So on our x-axis, we do have a nice industrial linear rail. On your side ones, we do have what they're calling adaptive rollers. And so that's still got your polycarbonate wheels, and they're running on rails that are built into the frame, but they are supposed to be kind of pre-tensioned and not require as much maintenance. Of course, you do have your belt drive on the side, and you have belt tensioning screws on the back of each rail. So a little bit of maintenance there that you're going to need to keep an eye on over time, but very typical of your diode lasers. Now on this one, they did include their automatic air assist, so it's the typical Sculpfun pump. Now in the past with the air pump, they did have this kind of thin-walled PVC hose. It was flexible, but it would also tend to kink. They now have some hosing that is a little more rigid, but still flexible, but it does not have that tendency to kink. So it's really nice to see that on this laser as well as a few of their other modules. And then their cable going to the module itself also has a nice thick rubber sheath on it, so it helps keep that protected, has some nice quality connectors that go into the module, and the cable management on this is very nice. It's all pre-done. It's wired and zip tied down, so it's kind of stays out of the way. It does not drag across the surface, and you're not having to like Velcro it and zip tie it down. All that is taken care of for you, and it seems to be working very well for me. Another feature they have on here is their precise focusing. So they have two different steps to the focusing. They have, of course, your lever, their quick release lever that allows you to slide this up and down very easily. And then you can also fine tune it on the back. There is a knob and that's attached to a lead screw. And that just allows for some fine tuning of the focusing. While it's not an autofocus, they've made it very quick adjust. They've made the precise adjustment, and quite honestly, autofocus on various machines have been very hit or miss for me in the past. I like a very simple design that's easy but allows that precise focusing. So I actually really kind of prefer this setup. Another thing that they've done is they've put the controller off to the side. It's over on the right side of the machine here, and then the cables point out the back and the side. I love that. I hate seeing the controller right up front and with cables sticking out of the top, getting into the way. They definitely listened on this one. They put the controller off to the side and allowed those cables to kind of go towards the back of the machine off the side. And so definitely easy to keep this out of the way. If you've got this built into an enclosure, you're definitely going to be able to route those cables easily and not have them get in the way of you bringing material in or out of the front. So as far as connectivity, they do have a typical USB-A style, and then it has kind of the original square connection, and this works well. I would like to see maybe them start transitioning into USB-C. That's becoming a little more typical on a lot of the newer computers, and so having if you have a newer laptop, you may need to get an adapter from the A to the C. So it would be nice if maybe they, in future versions, start looking at going to that USB-C standard. As far as other connectivity, they do have Wi-Fi as well as Bluetooth. However, that is limited to their mobile app. There is a desktop app where you can set up the Wi-Fi, so you can actually get this connected to your local network. It doesn't have to act as its Wi-Fi point and allow your phone to connect to that way. You can have it grab an IP off of your wireless network, and then you can connect to it via the app. Unfortunately, it does not work with Lightburn right now. It would be great to see that in the future as far as being able to connect to it remotely, but is nice that it will actually connect to your Wi-Fi instead of having to jump into its own localized wireless network. So now they also include some extension legs. There are some short, they're about 45 millimeter legs that are on the laser by default. You can pop the rubber feet off the bottom, and then you can screw in these extensions. These are 106 millimeters, or just over 4 inches. So that gives you close to 6 inches of height from the bottom of the frame down to your surface. So if you're using the rotary, this is going to be a nice way to get that lifted up. And this laser is compatible with the Sculpfun rotary, and so that is definitely an option if you're looking to do that with this laser. And we will be looking at that in a future video as well. Now, a couple of things that I've noticed while using this is the cooling fan on the module. On a lot of devices, they come on and they stay on, and that can be kind of frustrating when you're not necessarily actively using the laser. You might be in between jobs, but you don't want to power it down. Some of them stay on. Now, some of the lasers, it will come on and off with the job. This one, it will come on when the laser fires, and then it will stay on for about another minute or two to make sure that module cools down, and then that fan will shut off. So I think it's a pretty good way to do it. Make sure that the module is being actively cooled anytime the laser is on, and then it does have a cool down period rather than just cutting out that fan right as the laser stops. So the other cool thing I mentioned earlier, it has automatic air assist. Well, this one also, the air pump comes on once you power on the laser, but it comes on at a low pressure, and that keeps just a low amount of air going through your air assist nozzle, and that is great to help keep your lens cover clean, keep that smoke and debris away from there. But at the low power, it's not so much that it's going to blast that debris all over your engravings. So if you're the type of person that wants to run with your air off, you can leave that switch off in Lightburn, but there will still be just a slight amount of air moving through that nozzle to protect the laser cover lens and such. Of course, no laser would be complete without some safety features, and this one has incorporated a number of ones we've come to expect out of diode lasers. One that I really like, and the way they've implemented it is it has this e-stop right up front. You hit the e-stop, that's going to kill power to the laser, kill power to the motion control, and that will help you deal with an emergency and not have the laser continue to fire. To deactivate that, you just simply twist to the button, pops back up. I love that it's up front. I love that it's not surrounded by cables or other switches. It's there, it's easy to get at in an emergency, and that's how it should be. So kudos to them on how they implemented this. They also on the controller have a key lockout switch that you can turn the controller on or off as far as locking it out so it won't power on. So a lot of people would consider this like a child safety lock and such. So you would have to have that key to be able to activate the laser. Now, the nice thing is that you don't have to leave the key in while the machine is on. I've had a few other lasers where they have this feature, but the key has to stay in the laser. And that gets a little frustrating because now it's another thing that's just in the way. You can turn it on, remove the key, or turn it off, remove the key. Now, just make sure you don't lose the key. They do give you a couple. So if you are going to turn it off, just make sure you know where that's at. Of course, then they also have the tilt sensor. So if the machine tilts about 15 degrees, it will then air out and it will kill the laser and shut down the job. Along with that, they also have the flame sensor. And so again, if it sees the burning on there, it's going to kill the laser and move the head out of the way, which is a good feature on these lasers. Then, of course, it does have limit switches. They are good for homing the machine, but they also set the limits. So your machine will have soft limits, and if it tries to move outside that area or bumps into a limit switch, it will also kill the machine and tell you to reset because it's gone outside of its normal working area. Now, one of my biggest complaints about lasers in the past is the eye protection. Typically, they will send a pair of colored safety glasses and there's no rating on them whatsoever. Well, they do send, it's that similar style, and they are in that kind of safety glass style. And this is the first time I've seen this yellow color. But what you're always looking for in your glasses is that etched onto the lens of the glass, it should have its rating. And interestingly enough, this is one of the first ones where I've seen where they do have that rating on here, and this is saying it is for 200 to 460 nanometer wavelength and an OD4 plus. And so I'll try to get a close-up shot of that, but it is inscribed on the goggles here. So hopefully that means that these have been tested. They do have that rating on there, and you can be a little more assured that they will actually provide the protection for you. This is a 455 nanometer wavelength laser, and so these fit in that range. Now, of course, the glaring difference that we're seeing here from some of the other lasers I've looked at recently is this is still an open frame laser. It's not fully enclosed, and so that is something you're going to need to keep in mind when operating this laser. You can do it in an open air environment, assuming you have a lot of ventilation and everybody's wearing eye protection, but I strongly encourage anyone using one of these lasers, get an enclosure for it. Sculpfun has a variety of enclosures. You can build your own custom enclosure, but whatever you do, an enclosure will help keep that smoke and debris contained, and then you can vent it out. And it also helps contain the laser light. You can get safety glass, or hopefully the enclosure you purchase has that, and then you are less concerned about people walking in and not having their eyes protected. But it is something you're going to have to keep in mind. While these are open framed, they're not ideal to just let run out in the open due to the light radiation as well as the smoke and vapors that are created through the burning of materials. All right, so let's talk a little bit about the performance of this laser. Now, it does have a switching module. You can jump from 20 to 40 watts. So some of the tests I did do in both 20 and 40 watt. Now, when it comes to cutting, obviously I'm going to run it at the 40 watt. I don't really see a reason to run it at the 20 watt for cutting. You're just going to slow things down. And I don't think at that point the kerf is going to matter because you can adjust for kerf offsetting. So my cutting tests were all done at the 40 watt settings. Now, as far as that, I typically will test on 3mm or 1/8 inch Baltic birch plywood. This is actually a cabinet grade. I get it from a hardwood dealer. This isn't something you get at your big box store. And so it is a little denser, and so you may see slower numbers on this compared to typical craft hobby plywood. So I went ahead and set up that cut test, and here I ran it twice. This is the same material, but I always like to run it a few times just to make sure I'm getting a baseline. And you'll see there is some variations there, and that is most likely due to variations in the wood. But what we can see from here is that we're definitely cutting through this material at 600 millimeters a minute, all the way down to, and that's at 100% power. And we're getting through at 80 and 90 on this one as well. But as you can see here, we only cut through at 100% there. So I'm typically going to back it off a bit, say 10%. So I would actually run this at, say, 525 millimeters a minute or so, and probably about 90% power Now, I did also jump into some of the. It's a little bit thicker than 1/8 inch, but this is from Home Depot. This is some of their craft plywood. This is a birch with an MDF core, and you see it was definitely cutting a little hotter. We were getting through at 80, 90, 100 at 600, and there are those abnormalities down there at 500 millimeters a minute and 90 and 100, and that's, again, it's just because there's always spots in the material that are going to throw you off. And so that's where you want to get some quality material, and you also want to back it off a little bit just in case you run into those. So similar performance, but this is a little bit thicker material. So cutting wise, this is standing up pretty well to other 30 to 40 watt lasers. So now with that, always like to test my kerf. And so again, we just ran this at the 40 watt range. And to do that, what I run is I run 4 squares that are all the same size. So these are all supposed to be 25 millimeter squares, or roughly 1 inch. And then what I will do is I will measure it, the inside and the outside, get that difference both in the left and right and top to bottom. So that will give us both axes kerf. Now, these laser beams that are coming out of diode lasers actually tend to be more square than they are round, and they can sometimes be more rectangular. So you might have the diodes lining up more, a little bit longer in one direction than the other. So that can give you varying kerf settings. And what I ended up coming out with is I was getting a overall beam width, or a cut width of about 0.28 and 0.32. And so our kerf that's going to be the overall cut of the path. So if you imagine that beam riding on a line, half of it's going to be on one side or the other. So we want to cut that number in half. I took the average of them, and the average kerf is going to be about 0.15 millimeter, which again is fairly typical for these diode lasers in the 40 watt range. So looking pretty good, and not too far off, nothing that you're going to notice too much unless you're doing real intricate inlay work. Then that variation between top and bottom, left, right may affect you. Now, we not only can cut with this machine, but we can engrave. And so I went ahead and ran the engraving test, and this time I did it at both the 20 watt setting as well as the 40 watt setting. I ran them at the same speeds to kind of highlight the differences between the two. So this is on the same material. This is some of that Home Depot material, but closer to the 1/4 inch, but it is a birch plywood. And as you can see over here, this is the 40 watt, this is the 20 watt, and you can definitely see a darker gradient on that 40 watt. However, they both are working fairly well. So you could have some options to use either one. Now, if you're going for a photorealistic and you're just going to need a finer dot size, then you're probably going to want to go with the 20 watt. First off, you don't need to blast out the material so deep. So you're probably going to run it faster, as well as keep the power to where it's not getting a super deep engrave. But if you're running more of vector graphics, that they are going to be more of a solid color and just shaded, then you might want a darker and a deeper pocket. So with this information, I wanted to run a test to try to see, can we see detail difference? So I tried to dial in what are 2 similar colors on here as far as the darks, and that I could use for the 20 and 40. So we're not running the same speed on this, but we're trying to match the same color gradient, and then to look at the detail. So I ran the 20 watt at 9,000 millimeters a minute, and I ran the 40 watt at 15,000 millimeters a minute. These were done in Jarvis, and it was the same photo on the same material. And here you go. You can see the difference there. Obviously a little bit darker on the 40 watt, and possibly losing a little bit of definition. But again, it's going to be kind of up to you whether you see that quality loss or not. And in my experience, we are far more critical of our work than, say, our customers. And so you may be able to use that 40 watt, run it faster, and get the job done. So to look at more of a vector engrave, went ahead and took my logo and engraved it here on some 1/4 inch plywood. This was run at 15,000 millimeters a minute in the 40 watt setting. Ran it at about 75% power, and there is just a little bit of depth. But it's fairly consistent, fairly clean. I did just do a light sanding with some 320 grit sandpaper just to kind of clean it up a little bit. But overall, it came out very nice. And the cut, this was done, again, this is 1/4 inch plywood. This was ran at 500 millimeters a minute, 100% power. The overall job took about 26 minutes, and this is about a 5.5-inch square item. So just gives you a little idea of the time and the capabilities of this laser in cutting thicker material as well as engraving it. So of course the question is, how thick of material can it cut? So I thought I'd go ahead and try it on something fairly realistic. So I took this 3/4-inch Aspen, ran a couple tests. You see a couple holes here, and dialed it in at, ended up going 300 millimeters a minute, 100% power, and 2 passes. Find if I go any slower than that, you're going to actually get a lot more flare up, and that will cause the wood to be a little more charred and such. So sometimes going faster and extra passes is actually going to give you a cleaner cut and could result in a quicker cut. But here is the top and bottom of this piece. There is just a little bit of flare up on this section. So there would be a little bit of cleanup, but the edge of the piece, when you run it at 300 millimeters a minute, is fairly clean. So we're looking for just nice caramelization. You don't want that to be overly charred where it's going to leave a mess. Now, of course, with that, we also can play with some hardwoods, and a realistic size for this is really kind of that 6 millimeter or 1/4-inch material. So I had some cedar laying around and did a cut test on it, and it was cutting through this very cleanly. As you can see here at 400 millimeters a minute, we were still cutting through at 60. And so you could probably bump this up easily into 500, maybe 600. But again, depending on if you have some imperfections in this or higher, tighter grain in some sections, you may want to keep that down a little bit. But definitely cutting through this very cleanly. You can see on the front there, it's nice and clean. You can see on the back there, fairly clean. And so that's a very desired cut, so that it's not going to leave a lot of cleanup afterwards. So of course also ran an engraving test on this one, and getting very dark up here. So this was ran at 7,000 millimeters a minute on up to 17,000 down at the bottom there. And you can kind of see it's fading off here in the 10% range down at the bottom. So realistically, we're looking at a range of maybe 13,000 millimeters a minute to from 10 to 100% power, because we're just getting a little bit of drop off at the higher speeds of that. With that information, I was able to do a couple quick projects. And so went ahead and engraved and cut out a keychain, which of course has our keys that are going to hold the laser, and went ahead and threw the Sculpfun logo on there using the settings from our test. And this worked out pretty well. So this is a good beginner project to get started on. It's just a simple cut and an engrave. So it might be something you want to play around with yourself. And then of course, what we want to bump up into is more advanced projects. And so I took a little of some cedar that I had, 1/4-inch cedar, and cut out one of my gift boxes. Now this is a design that I have made where the lid can actually rotate around because of this wavy lid. It stays in place, but you can definitely rotate it around in any direction. And it's kind of a cool little design. This was cut out on this laser. Now I did go ahead and sand off and round over these corners just for look, but this is the type of thing that is very typical of this laser. This is a fun project that you can do easily with this laser, and definitely sell these or hand them out as gifts. So if you're interested in this one, I actually have a link to this file. It's on my Etsy shop. I'll leave it down below and you can check that out. So this is where I think I'm going to wrap up this initial impression video of the Sculpfun SF-A9. I hope this gave you an idea of its capabilities and its features. I really love that they have listened to the community on some of the improvements we want to see on these open frame lasers, and I think they're going to continue to expand on that. So I'm going to be doing more with this. As I mentioned, we have the rotary that goes with it. We're going to be doing some tests with that, as well as I want to jump into a few other materials with this, take a look at the quality, take a look at the engraving of slate and maybe some tile. So there'll be more coming with this. And if you want me to test something out with this, hit me up down in the comments. Let me know what you'd like to know more about this laser. So we'll see if I can get it into a future video. So I hope this gave you a good overview of the Sculpfun SF-A9. If it did, maybe hit that like button. If you're new here, hit that subscribe button. And of course, leave any comments you want to find out a little bit more or questions I didn't answer for you. we will be hitting up more with this on some project videos, and invite you to check out the rest of my channel for other things. A lot of information here, from projects to instructional, and I have some other reviews on earlier Sculpfun lasers as well. So definitely check those out. Otherwise, we will be back soon. But in the meantime, I hope you can out and workshop and make something too. We'll catch you next time.